In this video, all students will be able to graph an exponential equation that has multipliers. This is our third day of graphing exponential equations. Just like in the other video, we are only going to do one example together. So please pause, take notes as we go along, write down any questions you have. We're going to graph the equation y equals 3 times 2 to the x. 3 times 2 to the x. Okay, so let's go ahead and show our work over here. 3 times 2, I'm just going to go in order of the table to the negative third, okay? So I have 3 times, now this I'm going to kick to the bottom. 3 times 1 over, what's 2 cubed? 2 times 2 times 2 is 8. And 3 times 1/8, multiplying across the top is 3. And if you need to put in the invisible 1, you can, you don't have to. Across the bottom, 1 times 8 is 8. 3/8. We're going to plug in negative 2. I'm going to kick that 2 squared to the bottom. 2 squared is 4. Multiplying across the top, we get 3 over 4. So now I'm going to use the exponent of negative 1. That's going to get kicked to the bottom. Anything to the power of 1 is just itself. Multiplying across the top, 3 times 1 is 3. Across the bottom, 1 times 2 is 2. 3 halves. Oh, that's an ugly 3 halves, isn't it? Okay, let's get to those zeros and the positives. 3 times 2 to the 0 power. 2 to the 0 power is actually just 1, so 3 times 1 is 3. Y equals 3 times 2 to the 1 power. Okay, anything to the 1 power is itself. 3 times 2 is 6. Right? Okay. You know that the ratio, or I'm sorry, the base is 2, so really it's going to be doubling every single time. So use our positive 2, 3 times 2 squared. You'll notice that I keep doing the exponent first and then multiplying by the number that's out front. Okay, I just want to remind you, you have to do it that way. You have to take care of exponents before multiply, remember, in PEMDAS? In PEMDAS, you have to take care of exponents before you take care of multiply. So you'll notice I keep doing the exponents first before I multiply by the number in front, okay? I just want to remind you, PEMDAS, order of operations. And last but not least, if you noticed each number keeps doubling, 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 the next number, I'm sure you can make a guess at what that's going to be. Three times 8 is 24. Alright, so obviously not all of these points are going to fit on our graph. Okay, so let's see. Negative 3 and 3/8. Oh, geez. Can I even... It's way down there. It's a little bit under half. Okay, and then negative 2 and 3/4. Okay, right there-ish. Negative 1 and 3 halves. That 3 halves is equal to 1 1/2. So it's climbing still. Ooh. 0, 3. 1, 6. It's really hard to graph on this little graph. 2, 12. and 324. Well, I can't do that one. Okay. Oy. Hey, that one's not that bad. Okay. So there is our curve. So you'll notice that instead of just doing 2 to the x and being done with it, we had to take each number and multiply it by 3. So really what that did is it took all the points and moved it up. When you multiply something by 3, it's going to get 3 times bigger. So all of these outputs that are over here really got multiplied by 3, so that moves the graph up. Okay, the y-intercept. The y-intercept was the point 0, 3. I want you to think about where that point came from, 0, 3, right? It came from right here, but why is it a 3, do you think? Usually in all of our equations, when you use 0 as the power, if you put like a 0 right here, it would just turn this whole thing into 1. So why did it turn out to be a 3 this time? Well, it turned out to be a 3 because, yeah, this is 1, but then it got multiplied by this 3. Okay? So that's something to notice. The y-intercept, you can actually see the y-intercept in the equation. I'm going to take off all these circles and everything. Oops, I don't want to take off that. Okay. Okay, so the multiplier out front, it actually turns out to be the y-intercept. The x-intercept, there is none. Same as usual. It gets really, really close, keeps getting closer and closer and closer, but it never crosses the x-axis. All right, so your homework is to try number 2. Try number 2 to the best of your ability. Bring your work to class tomorrow, and we will begin by reviewing your work. Okay, so it's really important that you try your best so that we know and so that you know what your strengths and weaknesses are, and you can watch out for mistakes, and you can really learn from your work, okay? You want your education to be individualized. I want you to try number 2 to the best of your ability and bring it to class tomorrow. Thanks, honey bunnies.